Welcome to another lesson. Today we are going to be looking at test-driven development. It's all about delivering reliable code. This is based on two of the following sources. Martin Fowler wrote the book Refactoring, and Ken Beck wrote the book Test-Driven Development, where he used Martin Fowler's principles in what we call the 3 test-driven development principles. Test-driven development means you're writing tests and then writing code. Writing tests after writing code and afterthought is a waste of time. You'll end up with very complicated unit tests. Mocking introduces brittle tests, and you are not testing behavior. You are testing complicated code tests. That is not the principles of TDD. When you start thinking about testing before you start writing code, you'll end up making test-friendly code. And one of the principles that we do is where classes are tightly coupled, we decouple them. So in a microservice, usually controller classes are tightly coupled to service classes. We use helper classes to decouple these two. Another technique that we also do is we keep the code inside the service and inside the controller so simple that it basically leads to testing the code in the helper class. What we do is we do not put data changing code in the service, and we do not put data changing code in the controller. So whatever the service receives from the database or from any other classes, we are now talking the implementation, that we return unmodified. Whatever the controller gets from the helper, it returns that unmodified. So all the modification of the data takes place in one place, and that makes it easy to write tests, because now we have only one class to test, and that is the helper test. And later we will learn that we can mock the service implementation class if we use a service interface. We can take the service implementation class that implements the service interface, and we can replace this class in our unit tests with an implementation of the service interface from a mock service implementation. And that's where we introduce mocking. The first principles of test-driven development, you start by writing a failing test, and that is the red phase. Then you write the minimum amount of code needed to pass the test. Notice I put here dirty code to pass the test. Now we refactor that code once it passed the test, and the refactored code should pass the test. So now we have clean code that passes the test. Let's demonstrate this. So here I have written my test, and if we go and look in the customer helper class, I have created the helper class, but there are no methods. I'm going to use TDD to populate that. I want to have a method called save customer, and I will create this method. So you see it now created the method, and now when I run the test it should fail. Run as a unit test. And as you can see, the test failed. It's red. That was the red phase. So now we need to go and look at that helper class. And now we need to write code. To save time, I have written the code I need. This is the code I need. So let's put this code in here. And now we run the test. The test should now pass. One of the benefits of doing test-driven development is I can single step and debug my code. Normally in a Java project, you can only debug your code when the whole project is complete because you debug the project. But by writing unit tests, I can debug the the code, and I'm going to do that now. Instead of running the test, I'm going to debug the test. And it should stop here where I'm going to call the save customer method. The request was populated with data that we put this method here below, make customer. That's that method there. All this method does is to populate the required fields I want in my request. Now, if I go now and I say F6, it's going to take me now into the new code that I've written. So you see, I'm able to debug my code. And here I'm going to call the database. And I've successfully written to the database. And now I should be able to do my assertions, and I'm expecting a success code, which is a 200. Let's see. I'm expecting a success message. The request processed successfully. And that test passed. So that's one of the benefits that TDD gives you. Now, I have written rather complicated code. The next step is to refactor my code. So I want to take all this code pertaining to the customer out of this method and create another method. To save time, I've already done that. So I'm just going to go now and pull that code out. So let's have a look at our code. By pulling that method, creating a make customer method here, I've now landed up with basically 3 lines of code. If something fails, I'll return an error. Otherwise, I'll return a success. Let's run this again. Now, one of the problems with writing a test like this, you're talking direct to the database, you're talking direct to the services. We want to be able to test when a database is down or a service is down. One of the reasons is Maven will run these tests during the build process. This is the reason that we want to use mocking. So if the database is down here with this code, my build will fail. So you may have noticed that I put a message here. You need to disable this test when finished. So we disable this test like that. Now let's go and look at mocking. As I mentioned earlier, with mocking, you want to test with the system disconnected. You want to be able to have Maven build your project and not fail because of a service or a database being down. Projects don't get promoted to the test or master branches when that fails, and Jenkins or Bamboo deployments fail. So these are the reasons why we want to use mocking. Let's go now and demonstrate mocking. I've now got a class called the Business Helper Schizophrenic Mock test. I will explain how this thing works. What I'm basically doing is I'm calling a mock implementation of the service I want to use to test my helper class. So let's open this up. I create a simple class, and all I do is I implement the customer service. So the service, it implements the service interface. And then I make my default constructor private, and I add an overridden constructor where I pass it the enum of test type. I use that in my enum. I just use the .name to get the test type, and I put it in a switch statement. So every method that I have in my service interface, I will write the corresponding method with a switch statement inside. So if the case is passing, then I want to return success, and I also want to set the customer so that it's not null. However, if it's a failing test, then I want to set the response code and the response message, and I want to return that. The third case is when I choose a test that throws exceptions, then I want to throw an exception, and you'll see that I make my methods throws exceptions. I declare them that way so that now I can use this class to check the behavior. So the very first test is going to be passing a type passing. The next test is going to be passing a test type of failing, and the third test is going to be passing a test type of throws exceptions. A benefit that mocking gives you is the ability to write negative tests. That helps me to harden my code. I'm now sending a request to a service and I'm getting back a bad result. And I'm now able to check my code. It's running. My code is actually running. My business helper is running, and I'm able to now check that my helper class can handle bad code, and in that case I'm expecting to get a null customer, and asserting null will mean that I succeeded in this negative test. The next test is when I throws exception. Now in my code I am hardening the code by making it handle the exception, and it should return me back a response, and also I wanted the behavior to also return me back the original customer so that I can verify that in my test. So that was my principle here. If I run this test now, you should see that all three will pass. Let's run this. Takes a few seconds to run. And all three tests passed. I've now put a breaking point in here because, like I did with the previous type of test-driven development test, I also want to be able to use my mock tests to debug my code. So I'm now just going to debug this test here, this test method. And now we can single step through the test. And now we are going to call the helpers save customer method. You see, I'm now able to test my helpers, and that method called a validator, which validated my request, and it brought back a response that it was valid. Now it's going to call the mock clause. I should have put a breakpoint in the mock clause. I didn't do that. And the test ran successfully. Now this was using a simple mock class, which I called the Schizophrenic Mock class, because of the way that I could give it different personalities using my technique here, where I have a test type passed. Next we want to see how we can do this with Mockito. Now, a word of warning. When you use Mockito, do not use Mockito as an afterthought. Do not break the rules of TDD when you're working with Mockito and write code and then write a test. It is better to not write a test than to write a test as an afterthought, because you're going to land up with a brittle test that gives the people who have to support your code more hours of debugging than actual value of test. And that is because you broke the principles of TDD. Tests become very brittle. Let's now go and demonstrate how Mockito works. When working with Mockito, there's 3 things you need to know. We use an annotation at mock to mock the class that you want to test. So that is annotated at mock. We then use the annotation inject mocks to annotate the classes that you want to inject into your test. And then when we write these tests, you will see that there will be a when statement followed by a then statement. This is how you mock the behavior. So when I'm calling this method of this class, then I want to return that. So I create the customer that I want to return. So I'm actually mocking the behavior when I call that method. Another behavior that you can have, instead of then returns, you can also do then throws, where you can then specify the exception dot class will throw that exception when this method is called. So that's how you can use it for negative tests. And you can also use return for negative tests by creating another method that gives you bad values. So if I run this test now, and then I will single step it so we can see how it actually bypassed that class. The test passed. I want that so that I can right click and say debug. Now just something to point out to you. This method here, if I open the implementation, it's going to take me to this method here. But because I'm mocking behavior of this method, instead of the code calling this method, you'll see that it's not going to call it, it's going to mock it. So let's go now and debug this. We are stepping through this. And you'll notice that I ran the code to this method here, and it never actually went into the code. It got mocked. And if we look here now, we'll see that we did get an object back. So the assertion will work and the test will pass. F8, the test passed. So those are the 3 ways we can do test-driven development. The first way is the easiest way. However, it has its limitations in that it works with real databases and services. The second way, the code was simple, but it takes a lot more effort to use the mock class. And then the third way was to use Mockito. Now I want to demonstrate to you, having built my code and got it working, why I actually want my code not to fail when a test is down. So now I'm going to open the code in Maven, and we will demonstrate the SonarQube there. Project folder, yes. This is the project that we were creating our tests. What I'm going to do is I'm saying Maven sonar : and then I'm giving it this, which points to my server, and this part here is my login credentials, which I have set up on the server. Having done that, this should run now. And the test passed. Now we want to open it in the browser. And you can see my tests passed on SonarQube. But what SonarQube gives me is the issues, and it summarizes them over here. So it's told me that it's got 3 blockers, and these are to do with unit tests. I'm not going to address them now, but I will. I left them deliberately so that it can come up as a fail. And then these are issues that Sonar regards as critical. You've got duplications of code. So let's have a look at one of these. If you click here, you will notice it opens up the code. And it shows you in the code where this issue is. And it shows you what the issue is. And I can go in and assign this to myself. And then I can make a decision. If I fix the code, it's now assigned to me. Let me just assign it to myself. Administrator, right. So I've assigned that to me, and when I fix the code, you will see this will disappear. But if I don't fix the code, it will show that it was assigned to me. And it calls this a code smell. So these are the clean code principles, Uncle Bob. Something else that I want to point out is that this is not only for testing Java code. In fact, you can test Kubernetes. You can test, let's go and show you that. Somewhere here, Kubernetes, K comes before P. Where did I see it? Why are you hiding away from me? I'll find it just now. So you can test Kubernetes. It will test YAML, XML, and POM files, and JSON files. There it is. There's Kubernetes. And it will test HTML. It will test Python. It will test C#, C++, Java. Java is what I've been testing now, so Java should be there. I just need to find it. Java, there's Java. And what's interesting here is that it has 400 rules. These are all the rules that it used to test Java. I just want to point something out. SonarQube is so light that I actually have it running in a Docker container. I'm just opening up my Docker so that I can show you SonarQube. Here it is. I launched this 6 hours ago. And with that, thank you for looking at this lesson. I hope it added value to you and it will encourage you to use test-driven development. Please click the like button and also subscribe to this channel to help this channel grow. So have a look in the comments. Click on the show more link so that you can see what other videos we have in this series of training courses. Thank you for that.